In our last problems, which I called convenient problems, we were looking for values that were all an even multiple number of standard deviations away from the mean. Well, as I said earlier, that's rare. And you also need to learn to use z-scores to handle those situations where the values that we're interested are not an even multiple of whole numbers away from the mean. For example, let's stick with the fish example. We've got 300 fish. And as I say at the top of the screen, you can see that we're assuming the same population mean and standard deviation, which means mu is 15. That's our mean, and our standard deviation theta is 5. And first of all, we want to find out how many fish weigh greater than 17 pounds. Well, again, let's start with a picture. There's our distribution. Might possibly want to be one of the nicest bell curves I've drawn today. We know our mean is at 15 pounds, and we know that about there and there we have these 2 points that represent plus and minus 1 standard deviation. So they would be at 20 pounds and 10 pounds. And we know that the area bound by those two lines and the curve represents 68% of the area under the curve. This made it real handy for solving our earlier problems. But now, what do we want? We want to know, number one, 300 fish, how many are greater than 17 pounds? Well, let's draw 17 pounds in here. It'd be about 2/5 of the way between those points. We'll call it right about that. We'll slide a little 17 in there. And so we want number of fish greater than 17. So we're looking for this area under the curve. Well, unfortunately, that area does not correspond to plus or minus 1 standard deviation. However, we have this thing called the z-score that allows us to normalize. Normalize our value, and after that, we can look up in a book. We have a table full of values where if we take the z-score equivalent of 17, we can find out how much area is between the mean and that value. Let me show you what I mean. First of all, the z-score is defined as x, the value we're interested in, and in our case that would be 17, minus mu divided by theta. X, the value we're interested in, minus the mean divided by the standard deviation. In our case, let's see, we're interested in 17 minus the mean of 15 divided by the standard deviation of 5. That's 2/5. We find that z is equal to 0.4. So I'm going to go like that and say z is equal to 0.4 at that spot at 17. Well, how does this help us? We have a table, and I'm going to try putting my book up here if I can do that. I should have tried this earlier, but I didn't. Where we can look up z equals 0.4, and it'll give us a value. So here's our table, and let's see. Here's our table. Can I zoom in? I'm looking for 0.4. It's going to be 0.4 down here, so I want to zoom. How do I zoom with this thing? Let's try this button. Yeah, working. Okay, now I got to get to 0.4. So there's 2 columns here, and they were the z column and the a column. Z is on the left. So all we have to do is find 0.4, the z that we calculated. Here it is, 0.4, and you see what we're given, a corresponding value of 0.155. 0.155. So let's put that away for now and zoom back to where we were, hopefully. Something like that. We lost our word window. Let's get him back there. There we go. Close enough, right? And now we found a value of 0.155. And what the A value is, the value from the table is termed the A value, is the area between the mean and where the Z value was calculated. So it's this area right in here, between the mean and our value of 17. And they told us that that area is equal to 0.155, and I'm going to write these as percents, 15.5%. So this little sliver here between 15 and 17 is 15.5% of the area under the curve. Now, how the heck does this help us? Let's see what we got going here. 300 fish, how many are greater than 17 pounds? Okay, so we initially hatched in this area to the right. That's the area we want to figure out what it is. Well, let's see. The whole area to the right of the mean, that whole piece, we know what that is. That's 50%, right? So if the whole thing is 50%, if I subtract out that sliver, which we just found out was 15.5%, we should know what the percent is. We've crossed hash. That's the part we're interested in. The number of, or the percent of fish that are going to weigh greater than 17 pounds. Yay us. 50 minus 15 and a half. I don't want to make the same mistake twice. 34.5%. That's this area, the cross-hatched area over here on the right. So once again, we can take our 300 fish, multiply by 34.5%, and we'll find out that that is 104 fish. That's our answer. Of 300 fish, we would expect 104 of them to weigh more than 20 pounds. Let's move on to part 2. Do some more Z-score work. In this case, we're looking for a range. Looking for fish between 13 and 18 pounds. Same story. Mean of 15. Standard deviation of 5. Let's draw our bell curve. We know 15 is there. What are we interested in? We're looking, let's see, just for reference, I'm going to put my 68% values in here. Just nice to keep those in mind as a reference. 68% of the area under the curve is bound by those two lines and the top curve. That's plus 1 standard deviation, and that's minus 1 standard deviation. 15, 20, 10. Okay, got the picture. Now we're looking for the number of fish that weigh between 13 and 18 pounds. All right, 13 is about 3/5 of the way there. That's 13. And on the other end, we want 18 pounds, which is over here. 18 pounds. So we want to find the area under the curve between those two lines. Between 18 and 20. Yep, 300 fish. Between 13 and 18 pounds. How many? Well, let's see. What are we going to do this time? First, we're going to calculate some z-scores. We know we're going to have to do that. So, z. We're going to have one there. We're going to have one there. Z equals. Let's do the, let's do for 13 pounds. For 13 pounds, z is equal to x minus mu over theta, which is equal to x is our value, 13, minus the mean, 15, over theta, which is 5, which gives us a negative 2/5, which equals negative 0.4. All right, when we look up a z-value of negative 0.4 in our text, we won't find it. And what we have to realize is that the z-scores rely on the symmetry between the two sides of the normal distribution. And what you do is, even though we calculated a negative number, you look up the absolute value of it, the positive version of it. So we're going to look up 0.4 in our text. And when we do that, let me get on the right page over here on my notes, we find, there it is, okay. We find the number 0.155, and let me just confirm that. I'm looking up a z of 0.4. Oh yeah, we had that one in the last problem. We find the value 0.155. And what that value represents is this area. It's 0.155 or 15.5%. Recall that when we go to the table of z-scores with a z-value, we're given an area, usually represented as A. And it's the area between the value you're interested in our case 13, and the mean, which tells us that sliver, which I've now drawn in green, circled in green, is 15.5%. We're halfway to solving our problem. We know that we have 15.5% of the area under the curve over there. How much is over here on the right? Well, we just need to calculate another z-statistic. Simple enough. For 18 pounds, this point over here, z is going to be x, 18, minus the mean, 15, over 5, which equals 3/5, and that's 0.6. Once again, I need to go to my z-score table and find the value, go there with the value of 6 and find the A value. And when I do that, I find that this area, which is now this bigger slice over on this side, I don't know if you can see that that one's blue. We find that this area is equal to 22.6% of the area under the curve. Okay, well, now we know what the two slivers are. We know that this one's 22.6. We know that this one's 15.5%. We simply have to add those two together. So let's do that. We'll go back to orange. We've got 15.5 plus 22.6. That'd be 1, 5, 6, 7, 8, 1, 2, 3. We've got 38% of the area under the curve is between 13 and 18. And so if we want to know how many fish, we got 300 of them. We multiply by 38.1%, and we find out that is 114 fish. Yay. Number 2. Done. Let's do one more. The last one. Unless you guys tell me you need more, and I've encouraged you to email me and say, Craig, do a problem like the mastery exercise number 14. And I'll write back and say, you know what, randomizes them each time. Which one is number 14? You got to cut and paste it for me, and so I know which one it is, or rewrite it or something. You can't just say the number that you get, because each of us gets them dished out to us randomly. But I'd love to do that. If you need help with a problem, you don't like one, or you can't get it, tell me. I'll create a video, or I'll call you. We can work it alone. Whatever you want, guys. All right, last problem. Number 3, 300 fish. How many are less than 22 pounds? Same story. Mean of 15, standard deviation of 5. Draw the picture. Bell curve. Mean is 15. Let's see. Let's draw these guys in. I just like to have those as a reference, and I think you're going to see why this time. So that would be 20 pounds, right? The mean plus 1 standard deviation. The mean minus 1 standard deviation would be 10 pounds. Let's see. We want to know how many fish are less than 22 pounds. Well, where's 22 going to fall? It's going to be somewhere out here. It's going to be 22 pounds. And so we want, wow, a big area. We want all this area. That's what we want. Well, let's see. Let's think about this for a second. We know that that's 68% of the area, right? And it's out further than that to the 22 mark. So, gee, 25 out here. Let's see, that represents the 95%, right? The 95% of the area under the curve at that point, which means that that little thing's 2.5%, but that doesn't help us. We need this area from 22 all the way back. Fish less than 22 pounds. It's going to be a lot of them. Well, let's calculate a z-score for that spot. For 22 pounds. Z is equal to the value minus the mean divided by the standard deviation. Our x value is 22. We subtract the mean, which is 15, divide by 5. And what do we get? We get 7/5, which is 1 2/5, which equals 1.4, right? Yes, that's 1.4. Okay, now, can we go to the z-scores table with 1.4? Yes, we can. I'm looking right now to double check my figure, and I get a number at z of 1.4 of 4.419. So my z at this point is 1.4, and the table returns an a of 0.419. Once again, what does a z-score, or what does the a value mean? It's the area between the mean and the value of interest. So where we get double hatching here is that area between the mean and 22, and we know, we're told that this area is 41.9%. Well, that makes sense. Everything to the right would be 0.5, and yeah, looks like we're going to lose maybe 10% or 8%. Yep. So, how many fish weigh less than 22%? Is it just 41.9%? No. We also have to consider everything to the left of the mean. But that's a no-brainer. We know that everything to the left is 50%, right? And so now we can add those two values together. We've got 50% plus 41.9. We know that 91.9% of the 300 fish are going to weigh less than 22 pounds. And when we do the math, we get 276 fish. We would expect that 276 of the 300 fish that are caught in Sturgeon Bay, if they have a mean of 15 pounds and a standard deviation of 5, we expect 276 of them would weigh less than 22 pounds. Thanks, folks. Hope it helps.